Hey everybody, so let me just make this quick video for your asynchronous day. I wanted to just walk you through some of these factoring ones that people are having questions with. But I want to actually use one in which we're solving a polynomial equation. Because I may look at this equation and think, uh-oh, how am I going to find the values for x that are going to satisfy this? Because it looks a little bit intimidating at first. But if I take a lens of factoring, as you can see here, what's that going to allow me to do is actually break it down, hopefully in a manner that allows me to use some of the tools at my disposal. So I looked at my three terms and I saw that they all have a common monomial factor of 2x. So that would just leave me here with an x squared. That would be a minus a 6 and just 1x. And then that would be a 9 and no x's left. And I'm still going to bring down my right side of the equation. Ooh, already this looks pretty good because now I got a quadratic. So, ooh, this is actually, so what are the numbers? Sometimes I like to think of it this way. So what multiplies to 9, multiplies to 9, and what two numbers I should say, multiply to 9 and add to negative 6. Well, some of you, I can hear you yelling through the screen, negative 3 and negative 3. So I could factor as x minus 3 times x minus 3 or x minus 3 squared. This is going to bring me back to something that you probably remember from quadratics, something I like to refer to as the zero product property. So this equation was given to me equaling 0, which is quite nice. So the zero product property tells us, well, if we have a product that equals 0, if either part equals 0, for instance, if 2x equals 0, this would multiply out to be 0. Or if the x minus 3 squared equals 0, the whole equation would also come out to be 0. So you can look now here, if I divide by 2, well, one possibility for x could just be 0, or if you think about it this way, I could, take the square root of both sides, add 3, or maybe look at it and say, oh, well, if x were 3, I would also get 0. So my two solutions in this case, in a polynomial equation, my factoring actually worked out quite well. X could be 0 or 3. And we could call this a few things. Some people call them, well, they're definitely solutions, roots. If this were a function, we would call them the zeros because if we were just like f of x equals the left side. But in this case, we'll just call them solutions or roots for now. And the thing is, one thing you may remark on is the fact that this one it's like a repeated one. So if I actually went to graph this, I'm just going to graph it by hand. It's going to be a little bit different at that value. So I have a 0 at 0, and it's cubic, and it's positive, so it would pass through 0, 0. And I know that I also have, well, I did a poor job drawing that. Let me erase. These axes are quite crooked. Oh, man, oops. Even worse, but who cares? Alright, so I got a 0 here, at 3, and at 0. But because that one's repeated, it's just going to, you may remember from quadratics, it's just going to pass through and not touch. That's when we say if a 0 has a multiplicity of 2. So if I want to sketch the function, if let's say I just had this left side as a function, it could give me some good information there. So that's one technique to solve a higher degree polynomial like this, third degree. Let's try this one, which is fourth degree. Again, first thing, is there a common factor? Oh yeah, looks like negative 2. Oh, so notice this is asking a similar question but in a different way. So it's just basically, can you find the zeros? It doesn't look like I can take out any x's in this case. I'll take the negative out with it, but it's going to flip all these signs. So if I'm trying to find the zeros, I kind of got ahead of myself, I guess. I'm basically seeing what value of x would give me an output of 0. So basically, rather than just having it given to me in this format, or sometimes we have to isolate 0, Here we have to take that step. And this one didn't ask us to sketch a graph, but this one is explicitly asking us. So you may notice what's in the parentheses. Even though it's not quadratic, we have this sort of format where this is x to the fourth, and then this is half of that power, and then this has no x powers. So this is one where I could actually factor it as if it were quadratic. Just instead of an x there, I'm going to have an x squared as the first term in each binomial. So again, what is going to multiply to 16 and add to -8? Oh my gosh, it's kind of just like the last one. It's got to be -4 and -4, right? So I get x squared minus 4 and x squared minus 4. Or I could do x squared minus 4 squared. Oh, but wait, those are differences of squares, so I can break those down further. Okay. And then I guess I could rewrite it this way. X minus 2, I could put these two together to make it squared. And I could put those two together, make it squared. Okay, not too bad. So basically now, well, this is negative, and it's going to fourth degree, right? So we know it's going to be down to the left and down to the right. And we've got only 2 zeros. So you might say, Mr. Tannen, how are these only 2 zeros going to show up on my graph? Well, let's think about it. So it's just telling me we have a 0 at 2, positive 2 and -2. So because these also have a multiplicity of 2, it's just going to touch. Ooh, I could probably look right here, find out my y-intercept, because if I plug in 0 for x, right, it's going to be -32. So it's going to be, I can make these go by tens. So that's a pretty good graph, I guess, of it. I could even mark this as 0, -32, 2, 0, -2, 0. I would say it's a pretty good sketch. We know a few things are true about the sketch. We know the zeros are true, the y-intercept is true. Again, the y-intercept you could just get by finding f of 0, plugging in 0. So this would just be 0, 0, -32. So that's how I got that point. And we know the end behavior is true because it's a negative leading coefficient with even degree, like a negative parabola. So it's going down and down. So that's basically those two problems. So for this asynchronous day, hopefully you were able to make sense of this video. It should just come out to be less than 10 minutes. And then let me show you what else I got here for you. I'm just going to drop a few problems here. So the first couple are like practice, similar to what we just did. For number 2, you may have to set it equal to 0 first by subtracting the 14x cubed over. These ones you're setting equal to 0, seeing if you're able to solve. And then there's 3 multiple choice questions. So there's just 4 where you'll work it out, 3 multiple choice questions. You could do those in a notebook and upload a photo. I'll set the due date as Thursday for everybody on those. But I'll be on the call if anybody wants to hop in the Zoom for the asynchronous. You could finish that doc, but I think you have plenty of time. This video is not going to be 10 minutes, and then each of these problems will take you a minute or two. These are all multiple choice, 5, 6, and 7. And then you can submit that photo along, and then also don't forget the birthday thing is due by the end of the day on Wednesday. So hopefully this video was helpful, and hopefully people enjoy the asynchronousness of tomorrow. Much love, everybody. As you can see, it's getting dark over here. It's about 9:33 p.m. and just going to call it a night pretty soon here. Hopefully I can get some good sleep and come back raring to go in the future. Much love, everybody.